Hi everybody. In this video we will talk about molar volume, means volume of 1 mole of a substance. In particularly the topic that I'm going to discuss here, we will discuss the volume of 1 mole of a gas at STP. Okay, we have talked about 1 mole is equal to molar mass when it comes to the mass of a compound or element. 1 mole is equal to the Avogadro's number if you want to count the atoms, molecules, or formula units. So the topic for today is that what is the volume, how much space it is going to take. So at any gas, for 1 mole at any gas, it will take 22.4 liters. So but I want to discuss here is STP. STP is standard temperature and pressure. Okay, these are the values that you have to know. It is at STP, 1 mole of any gas will be equal to 22.4 liters. Okay, so this is our conversion factor when it comes to mole and volume. Now, what is STP again? As I said, standard temperature and pressure. Standard temperature will be 0 degrees Celsius or 273 degree Kelvin. So these conditions have to meet when we talk about 1 mole equals to 22.4 liters. What is the pressure? The standard pressure. It could be 1 atm, 760 millimeters of mercury, or 101.3 kPa. We have talked about pressure earlier on, so I'm sure you remember the kPa stands for kilopascal. Millimeters of mercury is another unit. Torr is another unit of millimeters of mercury. So not necessarily that you are going to plug these values in when we convert our moles into liters, but you must understand that this conversion factor is only true at STP. So when the question comes, it will mention that the temperature and pressure is standard. So let's do an example. What is the volume of 1.75 moles of carbon dioxide gas at STP? So we will solve the problem using dimensional analysis. The given amount here is 1.75 moles. So I write my given amount right here. My conversion factor is that 1 mole is equal to 22.4 liters. So as we know, for dimensional analysis, the mole section of the equation goes to the denominator and 22.4 liters goes in the numerator. I'm going to cancel my moles and multiply across, divide by this number, and that will be my answer in liters. Okay, so hold on 1 second, let's calculate the amount and we will go from there. So when I divide 1.75 with 1 and I multiply it by 22.4, calculator gives me 39.2 liters. I will take the whole answer because I need 3 significant digits. I have 3 significant digits here, 3 significant digits here, so my answer should be 3 significant digits. So let's go ahead and solve another problem. Okay, I am given 2.44 moles. So 2.44 moles. Again, the conversion factor is the same, that 1 mole is equal to 22.4 liters. The question is asking what is the volume. So volume is liters here, and 1 mole is equal to 22.4 liters. So 1 mole goes here. Again, the denominator, I multiply it by 22.4 liters. I cancel the moles out, multiply the two numbers together. The calculator gives me 2.44 times 22.4. It's a huge number. It gives me 54.6656. Now, if you pay attention, as I said, I need 3 significant digits here, 3 significant digits here. So my answer is going to be 3 significant digits. My last digit is right here. I have 5 about after that, so I will round it up. 54.7 liters is my answer. My third example, it says find the volume of 12.8 grams of methane gas at STP. Again, you must notice that every question is telling you at STP. The reason it is telling you at STP because the condition I told you that 1 mole is equal to 22.4 liters, it is only true with this condition of STP. So you don't need to be confused with STP. You just need to know that this is standard temperature and pressure. So 1 mole will be equal to 22.4 liters only at that condition. So that's all the purpose of STP is there. So let's go ahead and solve this question. This seems to be a two-step dimensional analysis because I'm starting from grams. I have 12.8 grams. Now, to cancel out grams, of course, I need grams here, which will be equal to 1 mole. So then I need to go one more step. That 1 mole is equal to 22.4 liters. So methane is CH4. We learned about organic chemistry already. So this is methane. Let's calculate the molar mass of methane. Carbon is 12.01. Hydrogen is 1.01. So my formula here is going to be, hold on one second, 4.04 and 12.01. Okay, it is going to be 16.05. So this is the molar mass of CH4. Okay, so once I know the molar mass of CH4, I will divide my grams. Okay, 12.8 grams is right here. I divided by the molar mass of methane, which is CH4, which is equal to 1 mole, and then 1 mole is equal to 22.4 liters. So grams get cancelled, moles get cancelled. You multiply across, divide by the denominator. And how many significant digits do you need here? I have 3 digits here, 4 here, 3 here. That means my answer needs to be in 3 significant digits. So let me go ahead and do that. The calculator gives me 17.864175. As I said, I need 3 significant digits because I need to go by the least number of digits, which is right here. I'm going to round it up right this. So my answer is going to be 17.9 liters because this is the only unit left. Okay, I have cancelled all other units. So 17.9 liters is my answer. Okay, let's do example number 4. Excuse me, I want to erase it. So let's do example number 4. What is the volume of 30 grams of ammonia gas? Okay, and here's the formula for ammonia. So what I'm given is 30.0 grams. You must understand that you need to write this 30.0. If you write 30 here, it will give you 1 significant digit and that will mess up your whole answer. So you start with 30 grams and then of course you need the molar mass of ammonia right here, which I believe is 17.03 grams, okay, which is equal to 1 mole. So grams will get cancelled. Molar mass is always equal to 1 mole, and then 1 mole is equal to 22.4 liters at STP. You know, this condition is given right here. Okay, so I have 22.4 liters. The grams get cancelled, moles get cancelled. You multiply across, divide by the denominator. Let's calculate this. When I calculate it, it gives me 30.0. I'm going to multiply it by 22.4 and divide by 17.03. I get 39.45977. I have more numbers than this, but I'll just stop right here. I need 3 significant digits, and my 3 significant digits will be right here. So I'm going to round this number up. My answer is going to be 39.5 liters. So I hope you understand what we are learning today is that volume of 1 mole of any gas at STP will be equal to 22.4 liters. So I'm going to erase this so you understand it better. The volume of 1 mole of any gas is equal to 22.4 liters at STP, where STP stands for standard temperature and pressure. The values for standard temperature is 0 degrees Celsius or 273 degree Kelvin, and the value of standard pressure is 1 atm, 760 millimeters of mercury, or 101.3 kPa. So these are the notes that you're supposed to take tonight, and we will do the practice in the class. So thank you very much for listening to this. I will see you in the class tomorrow. Thank you, everybody. Bye bye.